Welcome to the third lecture of the video lecture series on basic computer programming hosted by Coding Chip. Myself Chetan Kamani, lecturer in computer department at Government Polytechnic, Jamnagar. So in the previous lecture I have discussed various examples. That means I have solved various examples using sequence control structure of an algorithm. And today's lecture I will discuss few examples using selection control structure. So let's start. So by attending this session, you will be able to design basic algorithms using selection control structure. So let's start solution. Let's start discussion on the various problems which I will solve using selection control structure. Look at the first example which is written here. Write an algorithm to find maximum number of two given number. So before designing solution of any algorithm, you must have idea about the logic, right? You must have logic. So let us just discuss the logic. Okay, what should be the logic? Wait. Okay. So the problem is to find maximum number out of two given number, right? So how would you compare two numbers so that you can find maximum number? So definitely we have a comparison operator, that is either you can use greater than or less than. If a is greater than b, if a is greater than b, if this is true, then definitely which number is the maximum? A is the maximum. If it is false, then which number is the maximum? B is the maximum, right? So we have to write step according to this logic. First of all, I will take value from the user, number A, number B. Then I will compare both these numbers using this operator. If this statement's true, then A would be maximum, I will print. If it is false, then B would be maximum, I will print. Okay. And as I already told you, before you write any steps of the algorithm, you must have to specify the inputs. So for this algorithm, what would be the input? Number A and number B. What would be the expected output? Maximum of number A and number B. So let's write the steps. I will use Microsoft Word. I will not write the steps using digital board. Okay. So what would be the input for this algorithm? Think about this. What would be the input? Wait, I have problem with the mic. Okay, so our input would be number A and number B. What would be the output? Maximum of number A and number B. Okay, so let's write in steps. Step 1, definitely it would be start. Step 2, read number A. Step 3, it is same as of step 2, that is read number B. You can combine this step 2 and 3, you can make it one statement. Step 4, what is step 4? If A is greater than B, if A is greater than B, then if it is true, then we have to move to another step. That at this time I don't know which step number would be it. Now step 5, If step 4 becomes false, then definitely which number would be maximum? B would be maximum. Then print B is maximum. Then step 6, print A is maximum. Yeah, now you have idea about the jumping steps here from step 4. If A is greater than B, then go to step number 6. Okay, and step 7 would be stop. Okay, after printing B is maximum, the next step must be the ending step, that is step 7. Go to step 7. So what is this algorithm? To find maximum number out of 2 given number. That's it. Okay, this would be our input and this would be our output, and this is the solution of this number. Let's say A is equal to 5, B is equal to 6. In this case, the definitely output would be 6. Okay, start, read A, then read B. Now compare. A is greater than B. 5 is greater than 6. No, it is false. Then step 5 would execute. B is maximum, that is 6. Number B is maximum. Then go to step number 7. Then 7. The algorithm stops. Okay. So this is the perfect solution. Let me clear this. Okay. 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 This is the solution, right? So I hope you have idea about the solutions. If you have any query for this solution, then you can write in the comment box. Okay, let's go ahead with the second problem. That is, write an algorithm to find the minimum number out of 3 given number. It is same as the previous one. In the previous one, we have to find the maximum out of 2 given number, but in this case, we have to find minimum number out of 3 given number. So let's discuss the logic before we write the I can say solution for this problem. Okay, let's take 3 numbers A, B and C. This would be our input, and minimum out of the of 3 A and B would be our output. So we have to compare 2 numbers first. A is greater than B. If it is true, then which number is maximum? A. If it is false, then which number is maximum? B. Again, we have to compare this A with C. If it is true, then A is maximum. If it is false, then C would be maximum. We have to compare, we have to check for B with this also. If B is greater than C, we have to compare B with C. If B is greater than C, then B, if it is true, then B would be maximum. If it is false, then C would be maximum. Okay, so we have to implement this logic by using the steps. Okay, so what would be the input for this problem? Number A, number B and number C. What would be the output? Minimum out of this 3. Okay, but I have explained here the logic for the maximum, so let me change it again. Let me explain the logic for the minimum. If A is less than B, E is less than B, A is less than B. If it is true, then which one is minimum? A. If it is false, then which one is minimum? B. Okay, then we have to compare A with C. Okay, if A is less than C, then definitely A would be minimum if it is true. If it is false, then C would be minimum. We have to compare B with C. If B is less than C, then if it is true, then B would be minimum. If it is false, then C would be minimum. You can implement the previous logic for the minimum also, but generally I take less than operator, less than symbol for the minimum. Okay, so let's try to implement this logic. Okay, wait. Wait. So what would be the input for the problem? So what is the problem here? To find the minimum number from the three given number. Okay, so number A, B and C, this would be our input. Minimum of number A, number B and number C. So what would be the solution? Step number 1, start. Step number 2, read number A, number I am combining here, number B and number C. Okay, you can decompose step number 2 into 3 different steps, but I have combined here. Step 2, read number A, read number B and read number C. Then step 3, what would be the step 3? We have to compare A with B. If A is less than B, if this is true, then go to step which I don't know right now. I don't know the exact step number, right? That's why I have not written there. If it is false, then we have to compare B with C. If B is less than C, if this is true, then go to step, this is also I don't know right now. Then step number 5, print. If A is less than B, if it is false, then B would be B would be minimum, and we have to compare B with the C. If B is less than C, and this statement also false, right, then definitely which one is not minimum? Print C is minimum. Then we have to write step 6, print B is minimum. Step 7, print A is minimum, right? So you can see, if this is okay, I have made a mistake here. Okay, you can see in the step number 3, if A is less than B, if it is true, then we have to definitely compare A with the which number? If A is less than B, then definitely we have to compare A with which number? C number, right? So I forget to compare. Let's say, let me change the step number here. Step number 6, I have to compare if A is less than C. If A is less than C, then okay, let me change. If A is less than B, okay, B is less than C, okay, print C is maximum. Okay, then yeah, then go to step. Right now I don't know, right? If this is false, then if this is false, if A is less than C, then definitely C is minimum. So go to step 5. You can see I do not have to write the same step here. That's why I have changed the control to go to step 5. Okay. Now if A is less than C, which is also true, then go to step 8, then step 9. If A is less than C, then go to step 9. If A is less than B, if A is less than B, then go to step 6. If A is less than B, B less than C, then go to step 8. Okay. Now step 10 would be, don't worry, I will explain it. Step 10 would be stop. Okay. Then after printing C is minimum, we have to go to step number 10. Okay, after printing B is minimum, go to step 10. Okay, now let me explain this. Okay, let's take number. A is equal to 10, B is equal to 12, C is equal to 15. Okay, C is equal to 15. So definitely C would be A would be the answer. So start. हमने A को I have read already A, B and C. A is equal to 10, B is equal to 12, C is equal to 15. A less than B. Compare A with B. A less than B, which is true or false? You can see the value of A is 10, the value of B is 12, 10 is less than 12, which is true. Then go to step number 6. Then compare A is less than C. A is less than C. What is the value of A? It is 10. What is the value of C? It is 15. 10 is less than 15. Then definitely it is a true. Okay. Then go to step 9. A is minimum. You can see. Now let's check for another value. A is equal to 12. B is equal to 10. C is equal to 15. In this case, B would be our answer, right? So read A, read B, and read C. Then A is less than B. You can see 12 is less than 10. No, which is false, right? Then step number 4 would execute. What is the step number 4? Compare B with C. B is less than C. Yes, it is true. Then go to step number 8. Print B is minimum. Definitely it is working for this also. Now let's take another condition. A is equal to 10, B is equal to 12, C is equal to 9. In this case, definitely the value of C would be 9, the minimum, right? So if A is less than B, compare A is less than B. Yes, it is true. A is less than B because the value of A is 10, the value of B is 12, which is true. Then go to step number 6. A is less than C. Let's check. If the value of C is 9, the value of A is 10. 10 is less than 9. No, this is false. Then go to step number 5. Go to step number 5. Then check. Print C is minimum. Go to step number 10. Okay. You can write this algorithm in other way also. Let me write that. Okay, let me check. Okay. Let me again. Okay. I am going to write the same solution for that algorithm with different logic. Input. Okay. Input read. Input would be number A, B, and C. Output would be maximum of number A, number B, and number C. Okay, let's start step 1. Start step 2. Read number A, number B and number C. Let's compare A with B and C simultaneously with logical operator and step 3. Step 3. If A is less than B and this is the logical operator, A is less than C, A is less than B and A is less than C, then which is minimum? Which number is minimum? Definitely A would be minimum. Then go to step. Okay, if it is false, then compare B with both A and B. Step 4. If B is less than A and you can write alphabetical, and B is less than C, definitely which number is minimum? B would be minimum, right? Go to step, which I don't know right now. Step 5. If this is false, if step number 3 is false, if step number 4 is false, then which one is minimum? Print C is minimum. Then write step 6. Print A is minimum. Step 7. Print B is minimum. Step, look at the 1 2 3 4 5 6 7. Step number 8, that is stop. Okay, I have to redirect the control to the step number 8 from here. Go to step 8, same here, go to step 8. So this is the algorithm. Nice, right? It is nicer than the previous one and easy to understand the previous one. Okay, let's check this for the one number. I will not check for the 3 different numbers. Okay, now let's say A value of 10, A is 10, B is equal to 12, C is equal to 13. What would be the answer? A would be the answer. Let's say A is less than B. Yes, 10 is less than 12. This is also true. If this is true and this is true, then this statement would true. All of you are getting? That's why I will have used AND here. 10 is less than 12, it is true. 10 is less than 13, it is also true. Then go to step number, which step I will go here? Which one is minimum? Yes, step number 6, A is minimum. Okay, let me check for the another value. A is equal to 10, B is equal to 9, C is equal to 14. Definitely B would be the answer. A is less than B, this is false. If one of the condition is false, then this the result of this statement is false. Then go to step number 4. B is less than A, yes, it is true. B is less than C, it is also true. Then go to step number which? 7. I have to specify here 7. Okay, then B is minimum. Let's take for another value. A is equal to 10, B is equal to 9, C is equal to 8. Okay, step number 3, definitely it is false. Step number 4, B is less than A, value of B is 9, which is true. Then the second condition, B is less than C, B is 9, C is equal to 8, so it is false. Then the statement would be false. Which statement will execute? Print C is minimum. You can see the value of C. Now all of you have idea about the algorithm. You can see this would be the solution for our problem. I hope you have understood this. If you have any doubt regarding this solution, then you can write in the comment box. Let's discuss another problem. Okay, so let's just discuss the third problem. So what is our third problem? Okay, write an algorithm to find whether a given number is a given year, sorry, not number, given year is leap year or not. So before I implement an actual algorithm, let us just discuss the logic that you have to prepare, that you have to design for this algorithm. So for this algorithm, what would be our input? Our input would be a year, right? Year would be input, and output, what would be the output in this case? Whether a year is a leap year or not. So how do we decide whether the given year is leap year or not? So there is specific procedure to decide this. So how or what procedure we have to follow to decide, right? First of all, you have to divide year by 400, and if you get remainder 0, so there is a specific operator to find the remainder. Let me give an example. There is a specific operator in C language, right? Let me give an example. Suppose you have one number 12 modulo 5. So this is an operator to find remainder. This is known as modulo operator. Okay, I'm using this operator because in future when I start the operator section of the C language, at that time I will discuss this operator. But let me just give a little bit description, little bit detail about this operator. What is this, right? What this statement will give as a result. So whenever you divide 5 by 12, 5 2s are 10, right? And the here remainder would be 2. So this operator will give a reminder whenever you divide 5 by 12, right? So in this case we will use modulo operator. So first of all, we have to divide year by 400 and find the remainder. In that case, either we get remainder 0 or we get remainder not equal to 0. Okay, let me write in different way. Year modulo 400. There is a chance if remainder 0 or remainder not equal to 0. If it is 0, it is definitely a leap year. If it is not 0, then further I have to do I have to divide this year by 4 and check whether the remainder is 0 or remainder is not equal to 0. If it is not equal to 0, then it is not a leap year, right? Not a leap year. If it is 0, then further we have to divide year by 100, and if we get remainder 0 or if we get remainder not 0, right? If we get remainder 0, then it is not a leap year. Otherwise, if we get remainder is not equal to 0, then it would definitely a leap year. Let me revise this. First of all, we have to divide year by 400, and if we get remainder 0, if we get remainder 0, then definitely the given year is a leap year. If we do not get remainder 0, then further we have to divide the same year divided by 4, and if we get remainder 0, or either we do not get remainder 0. If we get remainder 0, then further we have to divide it by 100. If the remainder after dividing by 100 0, then the year is not a leap year. If it is not 0, then definitely it is a leap year. But if we divide a year by 4, in that case, then if we get remainder not 0, then definitely it is not a leap year. So let us see, let us implement this algorithm step by step. Okay, now input, what should be the input in this case? Any year, let's say capital Y. Okay, what about the output? Y is a leap year or not. Let's start solution. Step 1, it is definitely a start. First step is start. Step 2, read year capital Y. Step 3, if we have to check whether the given year Y is divisible by, completely divisible by 400 or not. That means it is divisible by it is completely divisible by 400 or not. That means we are getting remainder 0 or not. Y modulo 400 equal to 0, and it is definitely a leap year. But right now I do not know the step number. Okay, then go to, if it is not divide by 400, then we have to further divide by 4, y modulo 4, and if it is not equal to 0, you can see the symbol in future in C language we will use as a not equal to, right? Not equal to 0, then it is definitely not a leap year. Then go to, right now exact step number I don't know, the jumping step. Step 5, if y modulo 4 equal to 0, that means if I divide a year by 400, sorry, it is capital Y. If it is divided by 4 and if I get remainder 0, then I would have to further divide the same year by 100, y modulo 100. If it is equal to 0, then definitely it is not a leap year. Step 6, okay, if it is not equal to 0, then it is definitely a print y is a leap year. Step 7, print y is not a leap year. Okay, let's see, if y modulo 4 equal to 0, then that means if we get remainder 0 after dividing by 4, right, then it's definitely a leap year. Then what is the step number for leap year? Step number 6. Go to step 6. If the given number is not divisible by 400, that means not completely divisible by 400, then we have to further divide the same year by 4. If it is not equal to 0, then it is definitely not a leap year. Step number 7. If the given year is divisible by 4, completely divisible by 4, but the given year is as well as it is divisible by 100 also, then it is not a leap year. Step number 7. Then step number 8 would be stop. Okay, after completing this step, the control flow must go to step 8. Okay, so this is the algorithm to check whether the given number is leap year or not. Let me try to trace this algorithm by taking example. Suppose y is equal to, okay, y is equal to 2000. Okay, and this step is okay. This we have read the y. Then this step, y modulo 4, 2000 modulo 400, then it is definitely a 0, means we get remainder 0 after dividing 200 by 400, 2000 by 400. Then remainder 0. Step number 6, the given year is leap year. That means 2000 is a leap year. Let us take another example. Why 1900? Okay, so we divide 1900 modulo 400, 1900 divided by 400, 4 4 1600. The given remainder is 300, which is not equal to 0. So we have to further divide 1900 by 4 as per step number 4. Okay, 4 4 4 is 16, 9 minus 6 3, another 0, 4 7s are 28, 2 0 4 5 are 20, 0 0. That means it is divisible by 4. So we have to further divide 1900 by 100. Okay, 1900 divided by 100, 100 multiplied by 19 is equal to 1900. That means we are getting remainder 0. So as per step number 5, if we get remainder 0 after dividing by 100, then the given year is not a leap year. So y is equal to 1900, means 1900 year is not a leap year. I hope this algorithm is clear to all of you. If you have any doubt regarding this algorithm, then you can write in the comment section. Let's move further toward the next algorithm. Okay, so what is the next algorithm? Okay, what is the next and the final problem in this case? Yes, write an algorithm to find the roots of the quadratic equation. You must have idea about the quadratic equation, otherwise you will not able to write an algorithm. So let's try to search about this quadratic equation on the internet. Okay, quadratic equation, math is fun. Okay, now this equation is known as quadratic equation. Okay, x square plus bx plus c is equal to 0, and you have to find the root of this quadratic equation by calculating the discriminant. Okay, so let me explain this on the ppt. Okay. Okay, if you have seen the word ax square plus bx plus c is equal to 0, here a, b and c are known as the coefficient. Okay, so what we have to do, we have to calculate the roots of this equation. So how do we calculate the roots? First of all, we have to calculate discriminant. So what is discriminant? Generally in mathematics we call delta, but in this case we will use d. Okay, d is equal to b square minus 4ac. Okay, b square minus 4ac. So in this case, after using this formula, after putting this some value b or for b, for a, for c, whether the value of d would be less than 0 or equal to 0 or greater than 0, this three condition, right? If the value of d is less than 0, then roots of these equations are imaginary. If d is equal to 0, then both roots x1, let's say x2, both are same, that is minus b upon a. Okay, right, let's see, minus b upon a. And if d is the value of d is greater than 0, then roots of x1 is equal to minus b plus under root d minus upon 2a, and x2 minus b minus root d upon 2a. Let's see what we have to calculate. We have to calculate the discriminant, and based on the value of the discriminant we have to decide the types of root. If it is d is less than 0, then roots are imaginary. If d is 0, then roots are this. If d is greater than 0, then roots would be this. Okay, let's see on the internet whether it is same or not. Okay, you can see the roots. Okay, the solution of the quadratic equation can be calculated using the quadratic formula, that is x is equal to minus b. This is different formula. Okay, let me see on the Wikipedia. Yeah, so I told you delta, and in our case I will use not delta but I will use d. D is equal to b square minus 4ac. If the discriminant is positive, that means t is greater than 0, then the roots are two distinct value, minus b plus under root delta upon 2a and minus b minus root delta upon 2a. Delta in our case I will consider d. Okay, if discriminant is 0, minus b upon 2a, and if discriminant is negative, roots are imaginary. You can write like this, but in our case it is not necessary to write imaginary roots, right? Okay, let's start writing an algorithm. For this algorithm I will use Microsoft Whiteboard, because this algorithm has some mathematical notation, difficult mathematical notation, which requires special symbols in the word, and it would be very time consuming for writing an algorithm. Okay, so in this algorithm, let me okay, this is sufficient, right? So input would be a, b and c. Output, status of roots, or either we can say roots of quadratic equation, or you can specify the input, that is coefficient of quadratic equation, that is a, b and c. Let's start solution. Yeah, not this. Right. Then step 1, it always start step 2. What is step 2? Read a, b and c. Step 3, calculate d is equal to b square minus 4ac. Step 4, if d equal to 0, d equal, I will use equal to, right? D equal to, let me write again so that it would be very visible to you. D equal to 0, that means the value of d is it is equal to 0, then root something else. Step 5, if it is not 0, and if d is greater than 0, then go to, when I forget to write go to. Then step 6, it is not equal to 0, it is not greater than 0, then the roots, print roots are imaginary. Roots are imaginary. Then step 7, if it is d equal to 0, then the roots are print root. Okay, I will not use print here. Print root 1 is equal to, okay, sorry, not, I will not print, I will calculate root then print. Okay, then calculate root 1 is equal to root 2 is equal to what, is equal to what, minus b upon 2a, 2 into a. Then step 8, calculate root 1 is equal to minus b plus under root d upon 2a root 2 is equal to minus b minus d upon 2a. Then step 9, print root 1 and root 2. Okay, this is something bigger. Then step 10, stop. If d equal to 0, then go to step number 8, not 8, step number 7. Step 7. If d is greater than 0, then go to step 8. Okay, roots are imaginary. Already we have displayed the results of roots. Then directly we go to the step number 10. After calculating the root 1 and root 2, we directly go to step number 9. And after calculating this, we do not need to go to step number 9, because directly step number 9 is immediately after step number 8. So this is the algorithm to find the quadratic roots of quadratic equation. If you have doubts or if you have any suggestion for this algorithm, then you can write in the comment box. Okay, now so we have discussed for algorithm in this session. Okay, algorithm to find the maximum number out of 2 given number, to find the minimum number out of 3 given number, to find whether the given year is leap year or not, and the fourth one, the last one, find the roots of the quadratic equation. So I hope you have clear idea about this 4 problems, or if you have any suggestions for this algorithm, then you can write in the comment box below. And yeah, to get the future updates about this course or video lectures, do not forget to like, share and subscribe this channel. Thank you.